In this video, I'm going to walk you through how I made this studio lighting environment, which could be used for vehicles, props, and anything else that you can think of. Going over lighting tips and tricks, master material setups for both the background as well as the vehicle, so we can tweak anything in between that leads to our final render. Getting started, I have a basic level with no lighting, and I set our viewport to unlit mode so we can see what's in there since no actual lights are in the scene yet. Once we do have lights, we can toggle through the different viewing modes with Alt-4 as our lit and Alt-3 as our unlit, or manually select the viewing mode in the drop-down menu here with our other viewing options. In the world outliner, all I have is my mesh folder that has a background mesh and my custom speeder that I made. The background mesh is just a cube that I removed the top and sides from and then added a bevel and blender, which helps soften that transition and give us that depth of field look. So that's what I'm trying to showcase today, but any product or vehicle you have will be fine to follow along with. Just keep in mind you'll have to adjust some lighting values to match the size of your mesh. Mine is roughly 4 meters by 4 meters. Before we get too far ahead, let's go over some project settings. Go to Edit, Project Settings. On the left, we'll find Engine, and then Rendering, we scroll down some more. I'm using a UDIM workflow for my mesh, so we'll need to enable the virtual texture support. And then if we scroll down some more, my dynamic global illumination is set to lumen, and my reflection is also lumen. Scroll down some more. We want to use hardware ray tracing when available, and then switch the ray lighting mode to hit lighting for reflections. The last couple that we need are support hardware ray tracing and ray trace shadows. We can toggle on the ray trace shadows here, so every time we add a light to the scene in the future, it will use the project default setting. Or we can leave it off and toggle it on per light, since it isn't always the most performant thing to have on. There's honestly a lot of use cases where it just looks better to not have it on at all, but it's up to you. We'll use it regardless. It's just personal preference on how and when. Let's first swap our viewing mode to lit, and then in the quick add menu, find the rectangle light in the lighting section and select it. Rotate our light -90 on the y-axis, and we can drag this light up or down, or we can manually set its location in the details panel to something like 3000. Set the mobility to movable, so if it intersects with any of our other lights in the scene later, it won't cause us any issues. We want this light to be massive. It's going to cover the whole scene, acting like a giant softbox. Set our intensity to something very large like 7000. Increase the attention radius until it reaches the edge of your backdrop mesh. 7000 is perfect for me. Then make the width 11,000 and the height to around 8,000. These sliders are going to max out if you drag them, but you can type in any value above that you're going to need. Now that we can finally see some light in our scene, let's add our camera. Back in the quick add menu under the cinematics, you'll find a cinema camera actor. It pops up this little preview window of what the camera sees, which we can pin to the viewport so when the camera isn't selected, we can still see the view. I like to zero out the camera's location in the details panel and start fresh. So let's pull it back and get it somewhat in line where we're going to want it. Once that's in place, change our view from perspective to the camera we just created, and we can adjust some settings. The first thing you're going to need to dial in is your focal length. The default's 35, which actually works really great in this case, but do some experimenting with yours. The smaller the focal length, the wider your field of view, which really helps exaggerate your perspective and make your object feel big. Compared to a large focal length, it gives you a narrow field of view and really compresses your perspective. Under the focus settings, switch your method to tracking, then select the mesh you want the camera to be focused on. This way we don't have to manually adjust the focus to keep our mesh in frame every time we want to move the camera. Change the aperture to 8 so we get that deep depth of field, and that should do it for our camera settings. Next we need a post-process volume, which is where we edit all of the scene effects. You'll find that in the quick add menu under volumes. Once it's in, I like to drag it below the mesh so it's kind of out of the view and I don't select it by accident. In the details, search for infinite extent unbound and toggle it. This makes sure it covers the entire scene, not just what's inside the box. Exposure is going to have the biggest effect on our scene, so set it to 1:1 for min and max to disable auto exposure. Scroll down to local exposure. I like to mess with this to brighten up the shadows without having to brighten up the entire scene. Bump it down to 0.9 or so. Temperature also heavily changes the look of your scene. A lower number on the white balance gives you a blue hue, and a larger number makes it more of a yellow hue. I have a heavy metallic scene going on, so I personally wanted it more of a cold blue tone. Below that, we can tweak some lumen settings. Set lighting quality to 2. Scene detail to 4. In reflection, set the quality to 2. Now let's brighten up this speeder and really make it shine. First, let's split the viewport so we can make adjustments without affecting the camera and still see it updating in real time. In perspective, make sure it's default viewport and then click the 3 little bars. Find layout and then click the 2-panel setup. I like to have the camera on the left side and the general viewport on the right. Add another rect light and drag it into the foreground. This is going to be our key light. You can swap between move, rotate, and scale with W, E, and R. For this, I wanted to get it parallel to the mesh, and once we're happy with it, we can go to the details panel. Set our intensity to 100, set our radius to 2000, width to 3000, and height to 1000. If we take a closer look at this light, you can see a pretty harsh reflection that we don't really want. To get rid of it, we use something called a lighting channel. Every light and mesh have one. Something can only be affected by the light directly if it's on the same channel, and the default's always 0. Select the background and search for channel. Then set it to 2. Now you can see that only our speeder's lit. That's because our light's on channel 0, just like the speeder. So select our main light in the outliner and press Ctrl D to make a duplicate. Search for channel on the new light and set it to 2. Now our lighting's back just how it was, this time without the reflection from our key light. For the background, I wanted to use one mesh and only one material, but have a different look for both the floor and the wall. In the master material, I started with a texture object, connected that to a reroute node. I set that up as a triplanar so I didn't have to worry about UVs, then added a slope mask to control what angle the floor texture or color was projected on. Then connected the texture reroute node to some basic controls for the brightness, contrast, saturation, and color tint. I used the slope mask I created to alert between the floor texture and the basic color for the wall, then used the same method to blend between the metallic and the roughness. If you wanted to do that for a normal texture, instead of the world align texture, you just need to use a world align normal. Unreal treats those a little bit differently. After that, I created a material instance from the master, and if I pop this out, I can adjust the slope constraint. If I do 90, then the mask is projecting at a 90-degree angle, and a lower number like 1 would start blending the texture up the wall more. Then the contrast is going to control how sharp or soft that transition is. I wanted my floor to be metallic and reflective, so I plugged a metal imperfection texture for the floor and gave it some color. For the wall, I wanted it to have a matte finish and just a basic color, and this material made it super easy to fine tune. For the speeder, I'm using a UDIM workflow, so if we open the material, I start here with a base color that's set to a virtual color. Then I have some basic color controls for the brightness, contrast, and saturation. Another virtual texture that's an ORM, which is a packed texture that has our occlusion, roughness, and metallic all together as one that uses the RGB channels. I have my metallic, roughness, and AO connected to static switch parameters, so if I don't have a texture for those and I just want to use a basic value, I can use that instead. Then a basic control for my normal intensity, and finally a custom rotator that's connected to my UV scaler. After that, I created a material instance and did some fine tuning. That's the complete lighting and setup. Now we need to go over the render settings. Under Window, Cinematics, we need to add a sequencer. Then we're going to need the movie render queue. Right now there's nothing in it because we need to create a level sequence. In the content browser, create its very own folder like I did, then right click, and under Cinematics you'll find a level sequence. Name it LS for level sequence, then whenever you'd like, and then double click to open it. You'll see we have a timeline now, but nothing else. Click Add, then Actor to Sequence, and find the camera that we made. The numbers above the timeline represent the frame count, and Unreal defaults to 30 frames per second, and I'll stick with that. It also started us off with 150 frames, which is 5 seconds of footage. I want a 10-second clip, so 10 times 30 frames per second gives us 300 frames. We can hold Control and scroll out on the mouse wheel to zoom the timeline out. The only thing that gets rendered is what's between the red and green brackets, so drag the red bracket to the right till it's at 300. It's important to drag the camera cuts bar until it reaches 300 as well. It doesn't autofill when you adjust the time, and if it doesn't fill the space, it doesn't have anything to render. I want the camera to end up in the location we have it right now, and I want to do a subtle zoom in on the speeder that kind of swoops in from the top. Drag the marker to about frame 150, then press the diamond keyframe in the middle of the transform. This creates a keyframe for all three of our location, rotation, and scale all at once. Drag the marker all the way back to the beginning of the timeline, make sure it's at 0, then open up the location transform, pull back on the x-axis, then up on the z-axis, and finally add a slight downward rotation to the camera, and that's it. Now we can preview what we have so far, a smooth, subtle animation. If you wanted to speed up the movement, all you would need to do is bump the keyframes down to maybe 90 or 120. Just keep in mind our FPS is set to 30, so you'd want to do that in increments of 30. Now it's time to actually render this out, so click over to the movie render queue, then add render, and find the level sequence we created. You'll see the job name, which is what you name the sequence, the settings for the render, and the render output location. I have a settings preset I made already assigned here, but yours will say something else. Click to open it. These are all my settings I use for this type of render. You can delete what you have and I'll walk you through how to match mine. You can add any setting to your list from this drop down here. We'll start with what image sequence to use. The highest quality image export with the most color and image data is an EXR. This is industry standard, but the file size on these are absolutely massive, so keep that in mind. Deferred rendering is on by default. It renders the geometry first, the depth, the normals, the material data, then it applies the lighting afterward and screen space. Anti-aliasing is arguably the most important setting we can adjust. There are just so many routes we can go with this, and I encourage you to do your own experimenting and then lock in what's best for your scene. As I understand it, if you have no motion in your scene and you just want a really sharp, crisp, still image, use spatial samples, not temporal. For example, 9 spatial samples, 1 temporal, then override the aliasing and set the method to none. If you do have motion, then flip that. 1 spatial sample and 9 temporal and set the method to none. You do not mix these, it's kind of an either or thing. Epic and Unreal recommend odd numbers on the sample counts. You can use even numbers, but they're more than likely going to repeat or mirror jitter positions. I like to start at 9 and then max out at 23 when I'm experimenting. That window just seems to work really well for me, and anything above 23 I just saw diminishing returns. I had to do a lot of trial and error with this scene. I had a lot of hard edges, narrow gaps, especially around the engine. I set the spatial samples to 1, the temporal to 23, and then I overrode the aliasing and set the method to TSR. You'll get a warning at the bottom that tells us temporal or spatial count we entered is greater than what the engine's using. To get over this, all we need to do is type or copy paste a console command followed by the numbers of samples we used. I put the command in the video description so you can copy and paste right here. You very well could get away with just 7 samples and not have to use this command at all. That's what I mean by experimenting. If it still says an error, just toggle the override checkbox and that should do it. Toggle the render warm-up frames and set the warm-up count for both to 64. Just like you preheat a car, this lets the render start up for a few seconds and let all of the lighting and the effects settle. So when you start rendering the frames that matter, it all looks perfect. Game overrides is our last setting. This is pretty much a safety net that forces cinematic quality settings in case there are any LODs or anything else you might have done to improve your performance for the scene. That's it, just press accept, and if you're ready, click render local and it'll begin. After that finishes, we should end up with 300 individual images, not a video. I'm going to use Davinci Resolve to combine this all together. Open a blank file, but before you input any footage or images, go to your project settings. I like to start by making my timeline resolution 4K, but if you don't have a great computer, standard HD is just fine. Then we need to change the project frame rate to 30 so it matches the frame rate we just rendered in Unreal. Next, along the bottom, find the Edit tab, and make sure the media pool at the top is visible. Then select all our images that we exported from Unreal and drag them all in at one time. Then drag those onto the timeline. Davinci is smart enough to realize they're all in sequence and meant to be one clip, so it automatically combines them. You'll notice that the clip's way darker than Unreal and doesn't match at all. It's going to be a color space issue. Simple fix though, click on the color tab at the bottom and it'll bring up this window. This looks intimidating, but it's not. It's all just nodes you can drag and drop and then connect up. So find the ACES transform and drag it over the top of the line and connect the green to green if it doesn't automatically do it. For the input transform, scroll all the way down to sRGB linear, and then for the output transform, scroll all the way down to sRGB texture. And that's it, just the way it looked in Unreal. All that's left is to export this now, so click the Deliver tab at the bottom. At the top of this window is a bunch of presets, for example if you're exporting to YouTube, but since there's no audio in this video, there's not much to change. Start with naming your file, find an export location for it, switch the format to MP4, and make sure the codec is H.264. The resolution and frame rate should match what we set earlier in the project settings, but you can change it if you need to. When you're ready, select Add to Render Queue. That'll pop it to the right side of the screen in the render queue. Then all you have to do is select Render All. That should leave you with the finished render for your project. If this helped you in any way and you'd like to see more, drop a comment below and subscribe to the channel. I'll see you in the next one.